Hello, geometry class. Okay, today we're going to cover section 5.5, which is about inequalities in two triangles, compared with section 5.4, which was inequalities in just one triangle. All right, so let's look at this first example here. So where we have they have a picture here of a unicycle. All right, and when you look at it, you have the length from the seat to the center of the tire, right? That length is the same in unicycle 1, unicycle 2, and unicycle 3. And I just labeled it as C, all right? But then what happens is, depending on where this crank is, okay, so the radius of the tire, right, the radius itself remains unchanged, right? But as the angle here, angle A in unicycle 1 is an acute angle, all right, and the side opposite angle A is the length of B. If we look at the second triangle, the crank is in such a way so that angle A is a right angle, and now the length of B is longer than the length of B was in the first unicycle. And moving on, if you go to the third unicycle, as you crank that unicycle on or moving forward, right, this angle now is much larger than it was in the first unicycle or the second unicycle picture, right? So as angle A gets larger, B increases, all right? And that's what we're going to learn about today. So if we have two sides of equal length in a triangle, all right, but the as the angle gets larger, so given two congruent sides, now I mean when I say congruent, so comparing two triangles, you have one length in one triangle congruent to the length of another triangle, and then a second length in one triangle congruent to the second length in another triangle. So if you have side, okay, and then you look at the included angle, the larger angle will be across from the larger side. So let's look at how they say it, because they say it better than I'm saying. It's called the hinge theorem. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is opposite the larger included angle. So you see WX is congruent. They're telling us angle WYX. WYX, this angle here, is congruent to CAB. Hold on, let me mark it. Okay, so they're telling us the measure of YWX. So this angle here, okay, is greater than the measure of CAB. All right, and we know that WX is congruent to AB and WY is congruent to AC. So if we have two sides that are congruent, then we look at the angle, and whichever one is larger is opposite the larger side. So if in this situation, YWX, angle W is larger than angle A, that means that YX is larger than CB. And the converse of the hinge theorem says the opposite of that. All right, if two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is opposite the longer third side. So again, we're given the two congruent sides. DE is congruent to TU, and DF is congruent to TV. And this time we know that side EF, so this side here, is greater than UV. Well, that means then that angle D has to be greater than angle T. So it's a really simple theorem, all right? So if you have two congruent sides, then you have to look at the included angle, and you look at the included angle, and if one is larger than the other, that means the side opposite is larger, and then the converse is if the side is larger than the other side, then that opposite angle would be greater than the other angle. Okay, now let's look at this example here. You don't want to see me that big. I don't want to see me that big. Okay, so what are the possible values of x? All right, so now just notice here, it's a little bit DF is not a straight line, all right? There's DE, and it's not one continuous line. There's two segments here. So like DE goes like this, and then EF is like this. All right, so make sure you realize that. So these two angles here are not vertical angles, okay, that are congruent because they're not formed from straight lines. All right, so what we have here is what? So if we see we have a single slash here, so we're given that CE, right, is congruent to EG, all right, and we're also given that DE is congruent to EF. All right, so we've got those two congruent sides, so we have to look at the corresponding angles, all right, the included angles rather, so, and the opposite sides. So if we look at the third side, 18 is larger than 14. So that means that 2x minus 4 has to be larger than 36. Okay, and then they give us some more over here we have to look at, right? So we see that we also know that AC is equal to CE. So AC is congruent to CE, and we also know that BC is congruent to DE and EF, right? So let's compare those. So all right, so if we look at DCE, all right, so we know that what do we know? If we compare this triangle here and this triangle here, we know that the 60 degrees is greater than the 36 degrees. So we know that 21 has to be greater than 14. We already have that. All right, that doesn't tell us anything. Let's look at this one here. So if we compare these two triangles, okay, so ACB and DCE, we compare. We know that 21 is larger than 18, so because 21 is larger than 18, we know that 60 has to be greater than 2x minus 4. Okay, so we could really put this in one number sentence. So 2x minus 4, so we could really say that 36 is less than 2x minus 4, which is less than 60, and we can solve that. So if we add 4 to both sides of the inequality, we would get 40 is less than 2x, which is less than 64, and if we divide everything by 2, we get 20 is less than x, which is less than 32. So those are the possible values of x. Okay, let's look at the next problem. Okay, what are the possible values of x in this diagram here? So now we just have two triangles. So again, we have a single slash and a single slash, a double slash and a double slash. So the third side, the 12 is larger than the 10, which means that the 54 has to be greater than the 4x minus 18. All right, so if we add 18 to both sides, we get 72 is greater than 4x. If we divide by 4, we get 18 is greater than x, and you should always start with x. So x should be less than 18. All right, but x should be less than 18, but it can't. Now let's also be careful here. The angle, the vertical, the 4x minus 18 has to be greater than 0. So you're really also solving 4x minus 18 is greater than 0. So 4x is greater than 18. X is greater than 18 fourths. So x has to be greater than 9 halves. So that means that x is between 9 halves and 18. Just want to make sure I didn't make any careless errors here. 9/2 and 18. Very good. Okay. Let's go to the last one. What are the possible values of x in this diagram here? So we have two triangles, right? And we have, with reflexive property, they both share this common side. So again, we have two sides in one triangle congruent to two sides in another triangle. And we can look at the third side and we see that the 21 is larger than the 16, which means that the 3x plus 5 has to be greater than the 32. So we get 3x is greater than 27, so x has to be greater than 9. Okay, so just to sum up this section, it's really pretty simple. There's just two theorems, and the first is the hinge theorem. So given two sides in one triangle congruent to two sides in another triangle, then we look at the included angle to determine which one is larger. So if, in this case, if angle W is greater than angle A, then XY is greater than BC. And the converse of the hinge theorem is, again, if you have two sides in one triangle congruent to two sides in another triangle, and if the angle, if the third side is in one triangle is larger than the third side in the other triangle, that means that the included angle from the one that was larger is greater than the included angle of the one that was smaller. Anyway, hope that helps. Have a great day. Talk to you guys in next class. Bye-bye.